Everything is healthy and traffic is flowing. You check the cluster, the dashboards are completely green, and not a single pod is failing. But the component routing every single request into your cluster was retired on March 24, 2026. It's never going to receive another security patch. The cluster isn't going to warn you, and the controller won't automatically just stop working. Nothing is broken yet, and that is exactly why this is dangerous.
Look, in production environments, there is a massive, absolutely critical difference between an infrastructure component that simply still works and one that is actually maintained and safe. Your existing deployments of Ingress-NGINX didn't magically shut down on March 24th. The images are there, the Helm charts are still available, but there are no more releases, no more bug fixes, and crucially, no security patches when the next major vulnerability hits. You are essentially flying blind into the next exploit.
So what exactly was retired? We really need to untangle the Kubernetes networking terminology here because it's incredibly easy to misunderstand what actually died. Here on DevOps Corner, we care about what this change actually means when real production traffic depends on it. Let's be very precise. The Kubernetes Ingress API itself, that's fully supported. The underlying NGINX data plane, alive and well. And F5's NGINX Ingress controller, that is a completely separate project that is actively maintained. What was actually retired is the specific community-led, volunteer-maintained Ingress-NGINX controller project. That one specific implementation lost support. To be completely fair to the maintainers, this project really became a victim of its own massive success. We're talking about something that powered billions of requests globally, but it became critical infrastructure maintained by a tiny group of volunteers basically working on weekends. The technical debt piled up, some fundamental design decisions made security flaws harder to fix, and it just lacked the contributor base needed to safely maintain it. Retiring it was the responsible choice. Okay, so how do you know if your cluster is exposed? Well, you can start with a quick check. Just run a kube controller get pods across all namespaces using the label app.kubernetes.io/name equals ingress-ngx. If it returns pods, that retired controller is still routing your traffic. But keep in mind, finding the pod is just step one. It doesn't give you a complete inventory of the actual routing behavior keeping your applications online. Now, if you find out you are affected, you might be wondering, why isn't this migration just a simple YAML rename? Why can't we just swap out the target API resource, change the Ingress class, apply it, and call it a day? Well, anyone who has managed production traffic long enough will tell you, usually with a bit of a thousand-yard stare, the YAML is rarely the dangerous part. The undocumented behavior is. The native Kubernetes Ingress API is actually pretty minimal, meaning Ingress-NGINX had to add tons of capabilities through specific annotations, ConfigMaps, and custom default behaviors. Two YAML files can look logically identical to you, while behaving entirely differently to the cluster. This perfectly illustrates the edge cases you're going to run into. Think about regex matching. Does your new controller handle case sensitivity exactly the same way? What about a rewrite target annotation that silently alters path matching behavior? Or trailing slash redirects that your client apps completely rely on? Even source IP handling. These quirks can silently shift between different proxy implementations without throwing a single syntax error. So, the crucial takeaway is this. You can deploy a perfectly healthy new controller, and it can easily return unexpected 404 errors for your live customer traffic. Your infrastructure dashboard might be glowing green, but if you didn't account for those undocumented behavioral quirks, your customers are completely offline. This brings us to Gateway API, which is the most widely recommended target architecture for this migration. It solves the overloaded, monolithic Ingress resource problem we've been dealing with for years. But how does it actually change the underlying networking model? The Gateway API model separates concerns by roles. It flows like this. First, cluster operators deploy a gateway class in a gateway. That dictates the shared infrastructure and how traffic actually enters the cluster. Then, application developers independently own their HTTP route resources to define how that traffic reaches their specific service. It's brilliant because it safely decouples the platform team from the application teams. If you like production-focused DevOps breakdowns, give the video a like and subscribe to DevOps Corner. Now, what makes Gateway API incredibly powerful is that it natively absorbs a lot of the routing features that used to require those messy, controller-specific annotations. Traffic splitting, header manipulation, cross-namespace routing, native TLS configuration. These are just built right into the API specifications now. It gives you a much safer, portable, multi-tenant environment right out of the box. But here is the catch. Why does Gateway API still require you to pick an implementation?
simply because Gateway API is just a specification. Installing the CRDs alone doesn't route a single byte of traffic.
You still need an active data plane to do the heavy lifting. You have to evaluate your options based on conformance reports, the specific protocols your apps need, and your team's existing proxy expertise, whether that's Envoy, NGINX, or a native cloud provider load balancer. And hey, adopting an actively maintained traditional controller, like F5's NGINX Ingress controller, is also a completely valid and often simpler migration target.
To help with the translation process, there's a really handy tool called Ingress-to-Gateway. It reads your existing Ingress annotations and automatically outputs modern Gateway API manifests. But, and this is a big one, pay close attention to any warning logs the tool emits. It is a migration assistant, not a magic bullet.
You have to meticulously review those warnings. Ingress-to-Gateway will tell you what it couldn't perfectly translate, things like custom Lewis snippets or complex authentication flows. You absolutely cannot just blindly apply the generated YAML and assume you're good. A healthy controller does not guarantee equivalent routing. You have to test the actual requests and responses. Knowing all these potential pitfalls, what is the actual safest migration path to move live workloads off the retired Ingress-NGINX controller without causing a completely unforced outage? You have to use a parallel migration strategy. Please do not attempt a hard cutover on a Friday afternoon. You need to run both the retired controller and your new implementation concurrently. This timeline maps out the ideal flow: discover, test, shift, and finally, remove. Let's break down phases 1 and 2. Your job here is rigorous discovery and testing. You need a complete inventory of actual behavior, mapping out every config map, every snippet, and all unsupported annotations. Run Ingress-to-Gateway, figure out exactly what requires manual intervention, and then rigorously test the new controllers side by side in a staging environment that truly mirrors your production traffic. Phase 3 is where the rubber meets the road. You shift traffic gradually. Start with your internal, low-risk services. Use DNS weighting or your external load balancer to slowly bleed traffic over to the new controller. You have to actively monitor application-level success metrics and status codes, hunting for any unexpected 404s, while always preserving an immediate rollback path if things go sideways. Finally, we hit Phase 4. Once you've confirmed that absolutely zero traffic or platform automation relies on the old system, you clean it up. Delete those old Ingress resources, completely uninstall the retired controller, and update your platform runbooks so nobody accidentally deploys the old, vulnerable component again.
Bottom line, Ingress-NGINX will not shut itself down for you. It's going to keep routing traffic until your team actively chooses to replace it, or until an unpatched vulnerability makes that decision for you in the worst way possible. Continuing to work does not mean continuing to be supported. The safest migration is always gradual, thoroughly tested, and completely focused on real application behavior.
Subscribe to DevOps Corner for more real production breakdowns, and watch the next video on screen for another DevOps decision that creates unnecessary complexity.